Now in the revision paper 1 part 2 paper, so this part I'll explain answers to the last question of part A, that is question number 6. Right, then we move to question number 6. So that is constructions, easy question, so the student can do this one. So see here, using a straight edge of with centimeter, millimeter scale and a pair of compasses, following construction, show your construction lines clearly. So you have to construct a different one. Always they give an triangle, but here different one. Common number 1, construct the parallelogram ABCD using this data. Then you have to do another works, right? So before going to the construction, it is easy to draw a sketch, right? So using this sketch you can easily construct the parallelogram, right? So let's see the solution, the sketch, right? So better to draw the sketch. So this you can see parallelogram, right? So I'll draw the parallelogram, so name as ABCD. So then mark the given data, right? So they have given AB is 7 centimeter, so length of AB, so this is a parallelogram, you know, opposite side are parallel. AB length is 7 centimeter, right? So then ABC angle means ABC angle, so this angle is 120 degree, and also they have given the length of BC is 6 centimeter, right? So that is 6 degree. So this is the sketch. Now using this sketch you can start the construction, right? So here you can see, first you can construct the AB line, right? So draw a straight line, mark point 1 point, so then measure 7 centimeter, mark another point. So this point is A, this point is B, right? So length is 7 centimeter. Now you can see here, then you have to construct, right? Now we are going to construct the 120 degree using the so to construct the 120 degree, right? So first you have to keep the point of the pair of compasses at B point, right? So then draw a curve, right? So to construct 120 degree you should construct, so to construct the 120 degree you have to keep the point of the pair of compasses here. So without changing this length you have to mark arc. So this is 60 degree. Then again take the point of pair of compasses at this point, mark the same length again, right? So this is 120 degree. Then you have to join B point and this new point, then you get this angle is 120 degree, right? So then you can see here on this 120 degree line from 6 centimeter away, the point is C, right? So then mark this point, that is point C, right? So then it is 6 centimeter, right? Now see, now you should find the point D, right? So how to find the point D? You have to construct one line AD or another line CD, right? So anyway you can follow. Now I am going to construct AD line, right? So you can see here AD line means that AD line is parallel to BC line, right? AD line is parallel to BC line. So that is the property of the parallelogram. So that means you have to construct parallel line to BC through this A point, then you get AD line, right? So now I am going to construct parallel line to BC, right? So for that one I'll copy this angle, you can see here this angle, right? So in this right? So then I'm going to construct that one. So keep the point of pair of compasses at B point, draw an arc same length, take the point of pair of compasses at A point and draw the arc, right? Then come to this one, in the pair of compasses keep the point here and take the length of the pencil to here, right? So then come to here, keep the point of pair of compasses at this point and mark that this length in here, right? So that is how to copy this angle into another place, right? So if you draw this A, join A point and this new point, then you get parallel line to BC, right? So you know, in the parallelogram opposite sides are equal, right? So that means this side is 6 centimeter, this side also 6 centimeter, right? So you can take 6 centimeter to pair of compasses and mark that 6 points. So that is D point. Now you found D point, you know C point, then you can join these 2 points, then you get the ABCD parallelogram, right? So that is the Roman number 1, right? Now Roman number 2 say mark point E on the side BC, on the side DC, right? Sorry, the side DC, such that 4.5 centimeter away from D, right? So you can see mark D point, mark E point. So where is the point E? That is on DC. So that means that is on DC, right? But that is away 4.5 centimeter from D, right? So now you can take 4.5 centimeter to pair of compasses, keep at D point, mark that 4.5 centimeter on this DC line. So that point is E point, right? Right. Then another one is in Roman number 2, draw the triangle ABE, right? So how to take the ABE triangle? You have to join AE point and also BE point, then you get the triangle, right? So that is Roman number 2. Then Roman number 3, they ask another one is prove that the area of the triangle AB is equal to area of the triangle ADE plus area of the triangle BCE, right? Now we are going to prove that one, right? So that is a proof. So you have to remember this one, students, you learn in first term, remember area of parallelogram and area of triangle within same pair of parallel lines and between same pair of parallel line and on the same base, right? So there is a relationship between area of the parallelogram and area of the triangle, right? So we should use that one, right? So here also triangles also in triangle, right? So I'll move to solution. So you can see here using this that above theorem, right? So I'll explain the theorem. So you can write here 2 times area of the ABE triangle. So this is my ABE triangle, right? So I can write area of the parallelogram. So that is the theorem. You can see here theorem. What is the theorem? A triangle and a parallelogram lie on the same base. Now here see what is the same base. Both ABE triangle and ABCD parallelogram is on AB base, right? So that is the same base, and the between same pair of parallel line. What are the pair of parallel lines? AB and DC, right? AB and DC. Then area is exactly half the area of the parallelogram, right? So I'll make that half is multiplied by 2, then I get 2 times area of AB triangle, right? So that is the area relationship between area of triangle and parallelogram. Now they given to prove area of triangle AB is using the area of triangle AD. AD means this triangle, and the area of the triangle BC, this one, right? So you can see here, in the area of the ABCD parallelogram, you can write the extent area. The extent is area of ABCD parallelogram, you can write area of this triangle plus area of this triangle plus area of this triangle. So that is the total area of the parallelogram, right? So I'll use that one. So see here, 2 times area of AB triangle, you can write area of ABE triangle, you have to add area of ABE triangle plus area of BCE triangle, right? So that is equal to area of ABCD parallelogram, right? So now you can see here, to prove this one, right? So in the right hand side, see in the right hand side, area of the triangle ADE plus area of the triangle BCE. You can see here in the right side, area of ADE triangle plus area of ABE triangle plus area of BCE. So this area of ADE triangle we want, and area of BCE triangle also we want, but we not want area of ABE triangle. So we have to remove that one, right? So what I have to do? See here, 2 times area of AB triangle is equal area of ADE triangle and area plus area of ABE triangle plus area of BC triangle. Now I'm going to use axiom, that is what, subtract both sides area of ABE triangle, right? So that is by axiom. You have to write the reason. Then what happened? 2 times area of AB triangle subtract area of AB triangle. That's 2 times of area of AB triangle, you have to subtract 1 times of AB triangle. Then what is remain? Area of ABE triangle. Then what happened to the right side? The right side, area of ABE triangle, you have to subtract area of ABE triangle. Then that is also cancel out. Then remain here also area of ABE triangle, this side what we want, area of ADE triangle plus area of BCE triangle. So that is a proof.